Hello everyone, welcome to my third live presentation here. My name is Maliheh Mahdavi Sefat, and today I'm going to talk about Python modules and classes. This live presentation is the final task of a Step 3 Machine Learning Pass CS Internship program. We will have a quick recap of modules and classes, then we go and see a simple program in action to test what we learned. So what are modules? Modules are Python files that group related objects together. They avert name clash. They are imported in other files because they contain functions or classes that will be used in those files. They have a naming convention. Module names must end in .py extension. They are not supposed to execute directly. Instead, they provide utility and functionality for other programs. So how do we import modules? We can import modules in several ways. First, the basic import is to have the word import and the name of the library. This usually works for the built-in libraries of Python. Then there's the selective import. When we want a specific attribute or function from a module, we go like this: from mass import py and sqrt, and then we use that in py and sqrt only from the mass. There's the import with alias. When we have a third-party library that has a long name and we want a shorter name to use in our program, we can import with an alias. Import pandas as pd, and then we use that pd wherever we need it. After all, there's the import all. This asterisk here works as instead of everything. Is the unpacking way. When we want everything that's inside a module, we use this from mass import everything. This is not recommended due to potential namespace conflicts. What is namespace? Namespace is where an identifier, name of module, function, exception, etc. is. Local namespace is the block of code that the identifier is declared in. When we declare an identifier, the Python interpreter goes and first searches that local namespace. If it can't find it there, it would go out, level out to other classes, functions, whatever is out of the local namespace is the global namespace, and searches the global namespace. If it cannot find it in the global namespace, it would go to the built-in namespace, which is the Python language itself, and uses those names and identifiers. The first occurrence of an identifier that is found is given. Classes are practically data type that construct objects. They have the capcase naming convention. With this syntax def init, we initialize instances of the class, and we pass self, the special word self, as the first argument to the class to mention the instance itself. This syntax assigns a value to an instance variable. Dot variable equals value. We also have class variables that keep track of class level information. With this dot notation, we can also invocate or call methods. If we call the method on the instance like this, instance.method, this is the bound invocation. And if we call the method on the class itself and then pass the instance to it, this would be the unbound invocation. Methods in a class are three types of method in the class. There's the ordinary method. It doesn't need any decorator. It would receive the self as to mention the instances, to access and modify instances. The syntax is this: instance.method. And then there are class method and static method that both use decorators. This is the decorator at class method for class method and at static method for static method. Class method uses CLS word to mention the class itself. It is called on the class name dot method, and it operates on the class itself. But a static method don't need any implicit first argument because they don't have access to class or instance by default unless we say so, and they keep utility functions. There are private variable and private methods, and everything else is just public. We call them private names. Okay, private variables, private methods cannot be seen outside their scope. Therefore, they enhance security and prevent name clash. Their name begins with a double underscore. So, how do we access them? For accessing them, we have two ways. One way is to write a getter method and a setter method with this syntax def get, def set, and we just use the private name with its double score. In this way, the user must know that this variable, this name, is private, and we have to use a getter and a setter method for it, and they should know the getter method and setter method. But there's the second way. We can use a property decorator like this at property before calling the name, and we just treat that name after that like a normal name, normal variable with the dot notation without the underscore. And for setting it, we can use the decorator at the name of the method, which is the name of the variable or method, and dot setter. In this way, we can have a relationship or a formula between the previous value and the new value. We can have conditions here. Finally, there's inheritance in classes. Classes can inherit all or some of the attributes or functions of a parent. A class can inherit from several parents in several levels. We use this super function, super name, to refer to superclass, meaning the parent class, from within the subclass, the child class. We pass arguments from child to the parent through super. Therefore, there are hierarchical levels and hierarchical order. The general syntax is like this. We define a class parent, and we define instantiate instances with this def, init, self, and all the other parent arguments, and we do what we do with it. Then we define a child class child, and here we indicate that this child inherits from a parent. Then we instantiate the child instances with self and arguments. This super function calls the init of the parent and passes the parent arguments from within the child to the parent to make the parent instances, and we do the rest. Now let's go see some code. Here I have 3 files. One is module, and a utility module that I named race tool. One is the car module that includes some classes, and another is a testing program, just making the instances and testing them. I also have a copy of them, a complete copy with the doc strings and all to show the parameters and everything, but because I wanted to put as many line in the screen as possible, so I have a clean copy here. Let's see what we do with them. First, from datetime library we import date method, and from this race tool module that I wrote, we import racetime function, racetime method, and a scoreboard method. We have a class car that we want to create car objects with it. This car has a class variable cars, that's a list. We instantiate the car objects instances with model, manufacturer, and top speed. Then we have a function list car to list the cars one by one as a dictionary. We append the list of cars with this dictionary for each car. Then we have a class method tell cars info that just returns that list of cars. We mention the class itself with this CLS word. Sorry. We have a static method here. Am I online yet? We have a static method here. Def virage. It doesn't need any arguments, and it doesn't do anything special. It's just there to be pretty. This is the Doppler effect, yes. And we have the stir function and rep function. Both of them return strings that represent the object, but this stir function returns a human readable string. It cannot do anything. You can see the kilometer per hour unit here, but the rep string can be used with the help of an eval function to recreate an object of car. Let's see what we do with them. In testing car, we want to create 5 cars with models and the top speed kilometer per hour. If you're wondering, these are the cars we are talking about. Porsche 911, Lamborghini Aventador, Ferrari Pista, Bugatti Chiron, and modulus Tesla. Okay, we create the cars with this car class, then we list them, then we go on and want to get the list of the cars. When we print them line by line, or one by one. Okay, let's do this. Here is the result for that. These are the cars. These are the dictionary of the cars, model, manufacturer, and top speed. Okay. After that, we have another class race, that creates race objects. It has its own races list class variable, and another class variable that is total race. We instantiate each race with location and distance, and every time we instantiate another race, we increment the total race with 1 and assign it to the race number. Then there's the function list race, which is similar to the list car. List races in a dictionary form, append it, and we have this similar class method tell races to return the races list, and the similar stir function and rep function. Let's see what we do with them. Here I forgot to test this. When we create the races, we can also print one of the virage method on one of the car objects, and that would do this here. And we print the stir of one of the cars. This is the stir here. You see, it's human readable. It works for humans. And if we want the rep of car 1 would be this. We can put it into an eval method, pass it to the eval, which means evaluate, to be evaluated as Python code. And when we print it, print another car. This is another car. This is really another car. This is neither equal to car 1 nor the same as the car 1. You see that we get false. Then we go on and instantiate 4 races with location and distance. Distance is in kilometer. Monaco 3.3 kilometers. And we list the races and we get back the races. We print the virage, this time on the car itself, and we get this. These are the races in dictionary form, and this is the rage here, and go on. Then we have the class tournament. This tournament is a child of both car and race. It has its own race result list and another class variable outcome, which is a string. It will be a long text report, and we instantiate tournament instances with name and year. Here I didn't use super because I didn't need to pass any argument from within the tournament to the parent classes car and race. Instead, I put car.cars list and race.races list here as keyword arguments, and in this way we can pass any car list and race list from outside to the tournament class if the list is in the correct form. Because the name and year are common words, I made this name and year private variables to show you how it's done. For the name, I define the getName method and setName method, and whenever the user wants to know the name or changes the name, they have to use these functions. And for the property, and for the year variable, I use the property. In this way, I don't have to have a different name for it, just the year suffices. Then we return the year here. And for setting the year, we can have another value to the same name year and use it with dot notation, and I put a condition here. If the year is sooner than 2022 or later than current year, it would raise a value error. Otherwise, it would compare it to current year. We use date dot today method and separate the year of it. If the year is the current year, I wanted to return the exact date of today, and if the year is something else, it would return the year only. Here we instantiate a tour one instance of tournament with the name France Grand Prix and 2022, and print the past name with dot getName function and set it with dot setName. In this way, the user has to know that the name is a private name and uses getName and setName. This is the result of it. The past name is this, and this set name is Paris Championship. We changed it. We changed the name, and for setting the year, the user only uses this dot notation, the simple dot notation, nothing else. Tour1 dot year, and we pass the we set a condition here. This is 2024, so we get the exact day. If I make it 2018 and run the program, here we get a value error. You see, year must be between 2020 and current year. Okay, 2023 and run. Good, we got 2023. Next we go and see our main function here. This run race function is going to do the main job. For each race in the races list and for each car in the cars list, we want the program to calculate the race time with the car top speed and the race distance. Where is this race time? It's in our module here. This race time calculates the time that each car takes to cover the race with top speed and distance, and we put a random factor here to substitute all the other factors involved in a race. We name it driver factor, and we calculate the seconds, convert it to minutes and the remainder seconds, and return a string that looks like clock. Here, for each car and in each race distance we calculate the race time and append it to the race results list, like a tuple with the car model and the time it took, and we just sort it from the winner to the last one to the loser, based on the second element of the tuple, which is the time, and we go out of the for loop for car. This here tournament outcome is for the race loop. For each race we concatenate the outcome string first with the race location and race distance, and then for each tuple here in the race results we want it to be we want the string to be concatenated with the name of that car, in the order that they finished their race from the winner to the loser. And we just here I can print the race result to show you. Here's the race result here. We just instantiate a tor1 and get the report. Here is the race result for each list before emptying them. Result of race 1 would be that Kyron won the race with 36 seconds. Naiva 1 Turbo was the second place, 39 seconds, and etc. And this is the long string report we got each race with the cars in order. Okay, we're finishing, almost finishing here, and we want to print the scoreboard. What is a scoreboard? A scoreboard is here. We have a class method report that gave us the outcome, and we have another class method display scoreboard. Where is this scoreboard function? This is in the race tools module. I defined it. I got the idea from one of the exercism.io exercises. We just have a tab like this, race car with the number of first places, second places, third places, and the total score, and we make dictionaries to count the wins, second place and third place of each car, for each participant in the cleaned tournament report. We want to count them and give them points. Each win gains 100 points, each second place gains 40 points, and each third place gains 10 points, and the rest get nothing. And then for each car in the cleaned report, we just want to print a line like this, a formatted line like this, with the name of the car, number of wins, second place, third place, and the total point they get. Then we go on and sort that table first based on the score they get, which is the last 5 characters of the string, and then based on the name of them, and we return tab plus this table to the user. And here we want to print it. When we print this, we get this nice and clean report here, scoreboard here. Every time we rerun the program, we get a different scoreboard, because of that random factor. So this was my presentation. Thank you for watching it. If you like it, please like and subscribe to the channel, and follow CS Internship everywhere you are in the social media. Thank you. Goodbye.